So fractions versus decimals. Now, most of us like decimals better. We think they're easier to work with, and they are really. There's a lot of stuff we can do with decimals, way easier than we can do with fractions. And it's the idea of that place value that makes them easier. We got used to that place value. And that place value is just based on 10. So we forget about things like thirds and eighths and sixteenths and all those other fractions that are sometimes difficult. Now that's also a trade-off because fractions like 1/3 are not based on 10, that's based on 3. So we have this conflict. Now 10, think back to our number theory, 10 is 2 times 5. So fractions based on 2 and 5, since 2 times 5 is 10, are nice decimals. Fractions that aren't based on 2, 5, or 10 are kind of not nice decimals. So let's just look at a calculator and get a little peek of that. And I'm sure you remember seeing this before playing with your calculator. Like when we ask a calculator, what is 1 divided by 3? It gives me this decimal version of 0.33333. When do those 3's stop? Well, let's take a look at that. When we view a fraction as division, which is one thing a fraction means, we have the option of doing long division. And with long division, we say, how many times does 3 go into 1? And we know 3 doesn't go into 1. It goes into 1 0 times. But we learned way back in our youth when we did division of decimals that we could put a decimal place by the 1 there and write it as 1 0/10, which is still 1. And then we ignore the decimal point, sort of. There's a matching 1 in the numerator, but then we say, okay, 3 goes into 10. Oh yeah, 3 goes into 10 3 times. 3 times 3 is 9. Subtract, remainder 1. Oh, we still have a remainder, so we keep going. And we put another 0. 1 and 0/10 and 0/100 is still 1, but now I can bring that 0 down and say, hey, let's let 3 go into 10 again. 3 goes into 10 3 times. 3 times 3 is 9. Subtract. Okay, this is starting to get old because that 3 times 3 is 9, subtract 1 and get 1, subtract and get 1, subtract and get 1. Can you see that this is just going to keep going forever? I think I can stop here. So it turns out if there's a pattern in the remainder, that's going to lead to a pattern in the quotient, in the answer here. And it turns out the pattern in the remainder is more powerful than the pattern in the result. It's what leads to the pattern in the result there. And the problem is we're trying to force something that is not based on 10 to make it be only based on 10. And that just doesn't work. There's always a remainder and we get this thing that goes on forever. Forever is a problem because I can't go on forever. You can't go on forever. Our calculators don't go on forever. But theoretically, this kind of does go on forever. And it leads to these weird ideas. Like, check this out. 1/3 is 0.333 as a decimal, but you can't stop, right? If you do, you're not quite 1/3. You're always a little bit less. 2/3, let's check that out on my calculator. Well, that's 0.6666. Now the calculator threw a 7 at the end. Is that really a 7 and it stops there? Or did it round? And it turns out it rounded. Those 6's just keep going. If we stop, we're obligated to round. We don't have to, it's just an obligation. So let's see, 2/3 is 0.666, and those 6's keep going forever. Now what happens if you add 1/3 to 2/3? So I'm just gonna put a line underneath, I'm gonna add, well, 1/3 plus 2/3 is 3/3. What is 3/3? Well, it's really 1. Now on the decimal side, we'll reinvestigate this later, but we learned in our youth to line up the decimal point, and then to add fractions, you just need a common denominator. So 3/10 plus 6/10 is 9/10. And 3/100 plus 6/100 is 9/100. And 3,000 plus 6,000 is 9,000. And this just keeps going on and on forever, repeating 9s. Now, I don't know about you. I got pretty used to the idea of 1/3 as a decimal is 0.3 repeating. That 3 goes on forever, right? That's what that bar on top means. But this looks kind of weird to me, that 9's repeating forever is really equal to 1. Strange paradox, but true. If you accept that 1/3 is 0.33333 forever, that means 1 is 0.99999 forever. We'll look at that again some more later. So there is a little bit of a conflict between fractions and decimals. Can every fraction be written as a decimal? The answer is yes, but sometimes you get these weird repetitions that go on forever. Can every decimal be written as a fraction? The answer is yes. Whether it repeats or terminates, it can be. And just a reminder about that, let's take the decimal 0.125. That was slang. Oops. How do I really read it? Well, this is the tenths position and the hundredths position. This would be the thousandths position. So the proper way to read that is 125 thousandths. Boom, done. It's a fraction. I could reduce it, sure. I'm not going to. Bottom line is, if I see a decimal, I can make it a fraction. It's a little trickier to take something like 0.123 with just the 3 repeating. So what I mean by that is 0.12 and then only the 3 repeats, not the 1, 2. It's a little harder to write that as a fraction. I'll show you a trick later on how to do that. But we do have this trade-off that some fractions are just not going to make nice decimals. By nice, I mean it just stops when we plug it into a calculator. They're going to repeat. What's the reason? Well, decimals are based on 10. 10 is 2 times 5. So if we have a denominator that doesn't fit that right there, the decimal is probably going to be a little messy.